Today, I'm going to present a chapter from my thesis, which is the working paper, and it's called Inequality Resulting from Mismatch Between Mothers' Actual and Desired Labour Supply. So my motivation for this paper is that if inequality is a concern, comparing the labour market outcomes of males to females, as seems to be the common comparison, only provides limited information. What I find is that inequality within females as a group is more significant than inequality between males and females. And this is driven by the heterogeneous impact of motherhood on female labour supply, exacerbated by mismatch between actual and desired hours. So almost 80% of Australian females aged 15 and over are mothers. And I think it's important to try and first document and second try and understand why a significant proportion of females have labour market outcomes no different to males, whilst other females face a severe lifelong penalty, labour market penalty due to being mothers. So the gender pay gap, defined as the difference between median earnings of males and females relative to the median earnings of men, was documented as 12.3% for the OECD for Australia in 2022. Using Danish administrative data, some researchers have shown that the motherhood penalty can explain most of the remaining earnings inequality between males and females. However, earnings inequality within mothers or females as a group and how this is exacerbated between mismatch between actual desired hours is an under-researched topic, and this article attempts to fill this gap. So using Australian data, I find that approximately 1/3 of mothers don't participate in the labour market, and 1/3 of mothers work more hours than the minimum definition of full-time employment. So in Australia, full-time employment is regarded as 35 plus hours per week. So in the first 11 years of motherhood, 32% of females don't participate in the labour market, yet 21% work more than 35 hours per week. For the sample of all mothers aged 22 to 60, almost 30% don't participate in the labour market, yet 30% work 35 or more hours per week. And this bifurcation does not exist for males. So only about 4% of fathers in the first 11 years of parenthood don't participate in the labour market, yet close to 90% work 35 or more hours per week. And for all fathers aged 22 to 60, 7.5% don't participate in the labour market, yet over 80% work more than the minimum definition of full-time employment. So these basic descriptive statistics where 1/3 of women don't work at all and 1/3 of women work more than full-time hours either not noticed or not present in the data of other researchers. And these basic descriptive statistics is what is motivating my research. So here are some macro statistics from when records first began documenting the labour market from the Australian Bureau of Statistics. And the squares on this diagram is the employment to population ratio, and the triangles are hours conditional on working. So the black is for males and the grey is for females. What's striking is over the past 40 years or 45 years, the male employment population ratio has stayed roughly about 80. However, for females, it's rapidly increased. It was about 46 in 1975, raising to 71% in 2022. So there's been an increase of about 35, raising to 71% in 2022. So there's been an increase about 35 percentage points in females' employment population ratio over the past 40 years. But the hours over the past 30 years of both sexes have remained relatively constant. So males have decreased from working about 40 hours in 1990 to 39 hours in 2022. But females over the past 30 years have stayed relatively constant. If they do work, they only work 29 hours per week. So what's really startling is we see the employment population ratio increase from 45% in 1975 to 71% in 2022, but hours conditional on working stays constant at 29 hours. So whilst a woman today is much more likely to work than her grandmother, if a woman's grandmother worked, today that woman works roughly the same amount of hours as what her grandmother did. And I find that really startling that over 2 generations of women, the intensive margin of labour supply has hardly budged for women in Australia. And that's why I think that the intensive margin of labour supply, or hours, is crucial to understanding inequality in the Australian labour market. So my research questions are, does the motherhood penalty estimated at quantiles rather than OLS regression reveal more heterogeneity in female hours than is usually found? If desired hours are studied anchored to a person's position in actual hours gap distributions, does this change the amount of underemployment and overemployment? How does heterogeneity in hours affect earnings? And finally, is there more within inequality with respect to mothers and fathers, or more between inequality? If there is more within inequality, is it due to inequality within the group of mothers or fathers? Is inequality due to the price or quantity of labour? So I fully recognise that there are structural constraints in the labour market to how many hours a person would like to work. A person cannot just decide how many hours they would like to work and be given those exact hours. Nevertheless, I think I think it's important to quantify the extent of disutility that exists in society due to mismatch between actual and desired hours. And I intend to document this in this article. So Golden noted that the incentive for firms to disproportionately reward some occupations for working excessively long hours and how this contributes to explaining labour market inequality, particularly for females. So Claudia Golden has noted in both articles and books that in many high-paying occupations, the elasticity of earnings with respect to hours worked is greater than 1. So Golden has found that in jobs where workers cannot be close substitute, such as business or law or some medical specialties where face time is important, these occupations disproportionately reward higher wages for working longer hours. Bell and Blanchflower have explicitly described the increased wages of the overemployed as a form of compensating differential. Overemployment, as well as underemployment, have been linked to unhappiness, anxiety, and depression. It could be advantageous, for example, for a firm with fluctuating product demand to increase existing workers' hours rather than hire new employees. So if employers know employees dislike working very long hours, they need to incentivize them with a higher hourly wage. On the flip side, there are incentives for firms in some markets to keep employees underemployed, primarily through monopsony power. So monopsony power refers to when the buyer of labour, or firms, have power over the setting of prices or wages over the sellers of labour or employees. If employers know that employees feel underemployed, employees are so grateful to work just 1 extra hour that employers can get away with paying them the minimum wage. So if people are underemployed, they're so desperate just to work 1 extra hour, they can be incentivized to work at a very low hourly wage. So what happens is that overemployment and underemployment have opposing effects on the hourly wage, where overemployment increases the hourly wage and underemployment decreases the hourly wage. So hence underemployment and overemployment, through their opposing effects on hourly wages, exacerbate earnings inequality already due to heterogeneity in hours. So the motherhood penalty usually refers to how motherhood significantly decreases the earnings of mothers, either in comparison to fathers or childless females. And in recent years, the motherhood penalty has most rigorously been studied using event study and difference in differences models. So I found several studies that have looked at how parents' desired hours change during parenthood. However, all of these researchers studied desired hours at the mean and did not attempt to link parents' desired hours to the position they belong to in actual hours distribution. So in comparison to the results that I will show from my article, these studies are characterized by low effect sizes. 2 studies from sociologists have linked the motherhood wage penalty to lost work experience. So Paula England found a higher proportionate wage penalty for mothers at the top of the income distribution using quantile regression. However, once England accounted for wage penalties net of experience, they did not find a larger wage penalty for highly skilled mothers. Glauber, also in the United States, found the motherhood wage penalty for high-earning females had been eliminated by the early 2010s, whilst low-earning females continue to pay a penalty. My research offers an explanation for these findings, as I find that females who work very long hours pre-parenthood continue to work long hours post-parenthood, so these mothers would not be receiving a wage penalty for lost experience. Importantly to note, these two researchers that used quantile regression to study the motherhood penalty wages did not account for selection into employment in their model. So if people are more likely to work the higher hourly wage they're given, as is usually found, these researchers would have found biased results. So in other strand of research that's relevant to me, Heckman and Borges have studied state dependence for unemployment. Applying these ideas to overemployment and underemployment, other researchers have found both the creation and resolution of under and overemployment become more likely the longer the current spell continues, but less likely the more spells already occurred in the past. That's why I have two samples in my study. I study first-time parents, and I also study all parents aged 22 to 60. And what I found is that there's a lot of underemployment in the first birth sample, and there's a lot of underemployment in the all mother sample of 22 to 60. So if mothers are underemployed for 10 years of the first 10 years of parenthood, this is a long enough spell for them to be a scarring effect of mismatch between actual and desired labour supply, as I will show. So I saw data from HILDA, or the Household Income and Labour Dynamics in Australia survey. So HILDA is a household panel data set, and it is intended to be representative of the Australian population. So it's funded by the federal government. Australian data is very suited to my research questions on a wider scale, given that Australia has significant labour market flexibility compared to other OECD countries. So in Australia, 25% of employees are casual, with this percentage being roughly constant over the last 20 years. And a casual employee is distinct from part-time or full-time. So 25% of employees are casual. And what that means, there's no advance commitment by either employer or employee of ongoing work. Given this uncertainty, employees are compensated, depending on the industry, by 10 to 25% higher hourly wage than permanent employees. They are also given casual employees significant labour market rights. For instance, they're entitled to paid long service leave. Also, in some industries, after a certain tenure, you have the legal right of casual conversion to permanent employment. But many people prefer to remain casual employees because of the higher loading of 10 to 20% higher hourly wage. Importantly, in terms of developing countries, Berniel et al. Studied female labour market participation in Chile and found that first births increased female participation in the informal labour market by 38%. So given the extreme flexibility of the Australian labour market, where 25% of employees are casual, the result of mismatch between actual and desired hours that I find due to motherhood in my article in Australia could be presumed or extrapolated to be a lower bound than what may be found in other OECD countries with more rigid labour market structures. And importantly, my data set asked respondents their desired hours, taking into account how this would affect your income. And reservation wages are consistently below real wages for each year of my sample, as I will show. So I study first-time parents in a differences and differences model where post-parenthood outcomes are compared to pre-parenthood outcomes. And this is for a sample of about 1,200 couples. Then I study all parents 22 to 60. And the counterfactual of being a parent is being childless in this sample. And this sample consists of about 18,500 couples. So for the first birth sample, close to 65% are satisfied with their hours. About 20% report being underemployed with the desired hours of 23.61 hours. And about 16% report being overemployed with desired hours of 25.25 hours. So it's really striking as both the underemployed and overemployed have the same amount of desired hours. For all mothers aged 22 to 60, 60% are satisfied with their hours, 20% report being underemployed with desired hours of 25.6 at the mean, and 20% report being overemployed, with these overemployed people desiring 27 hours at the mean to work per week. And once again, for mothers aged 20 to 60, those who are overemployed and underemployed roughly desire to work the same amount of hours. So there's much less heterogeneity in desired hours compared to actual hours in the population. Here are graphs of reservation wages. So on the left is for the first birth sample, and for the right is for all mothers aged 22 to 60. So the grey line is mean actual wages, and the black line is reservation wages. And what you can see is that for each year of the sample, the reservation wage is $5 to $20 lower than actual wages at the mean. So clearly people are not unemployed because they have unrealistic expectations of what they would like to be paid. There's other things going on in the labour market to explain why people are underemployed, such as affordability of childcare. So I study couples hours gaps. I define couples hours gap as female partner actual hours minus male partner actual hours. And I define couples desired hours gaps as female partner desired hours minus male partner desired hours. So if I studied female hours singularly, this would violate the assumption of OLS regression of normally distributed error terms, as there would be many zeros in the data. So standard models that account for selection into employment are not appropriate for my analysis, which relies on quantile regression. So I show in the appendix that male actual hours and male desired hours barely change due to parenthood. Therefore, changes in couples hours gaps can be attributed to changes in female partner actual or desired hours. So as presaged previously, I studied couples' desired hours gaps relative to the location in actual hours gap distribution. For the first sample, I take the mean of their actual hours gap pre-parenthood. I then divide this distribution into 10 deciles and note couples rank in this distribution to study desired hours. For the sample aged 20 to 60, I take the mean of the actual hours gap of the childless couple sample. I know which decile rank childless couples and parents are in this distribution and study couples' desired hours based on this rank. So for the first birth sample, the counterfactual to being post-parenthood is being pre-parenthood. And for the sample age 22 to 60, the counterfactual for being a parent is for being childless. So I would like to illustrate how misleading it is studying desired hours at the mean using some basic descriptive statistics. So I'd like to column, the final column, post-parenthood, the difference. So post-parenthood, females would like to work 1.24 hours more. Males would like to work 1.57 hours less, and couples would like their gap to be 2.84 hours less, or the female partner relatively to work 2.84 hours relatively to the man. And for all couples aged 22 to 60 who are either both parents or both childless, we can see very similar results. So for females who are parents, they would like to work 1.09 hours more. Males would like to work 1.29 hours less, and parents who are 22 to 60 would like their couple's hours gap to be 2.43 hours smaller than what it actually is, or the female partner relative to work 2.43 hours more. So here I have the post-parenthood couples' desired hours relative to their position in the actual hours gap pre-parenthood, the 10 deciles, and I'd like to draw your attention to column 3. So what we can see in the first decile, where the male partner works more hours than the female partner, couples desire for the hours gap to be 12 hours less. Now going up to the 8th decile, there's no statistical difference between couples' hours gaps. At the 9th decile, the male partner would like to relatively work 1.6 hours less than the female partner relative to the female partner. And the 10th decile, the male partner on average would like to work 9.37 hours lesser hours relative to his female partner. So this is very different across the distribution compared to an average of 2.5. So I have two key estimating equations for my two samples. The first estimating equation is for the first birth sample. So the first variable is a post-baby indicator variable. So this takes the value of 1 for being in the first 11 years post-parenthood, and 0 for being in 5 years pre-parenthood. So I require all couples to be in the sample for a minimum of 2 years pre-parenthood and 2 years post-parenthood. So what I find, and what nearly every other researcher has found who has studied event studies of motherhood, is there's slight pre-trends the year directly preceding birth of mothers' late market behaviour. So this makes sense if we think most people get 8 months notice they're going to be parents. Some women go on maternity leave several months before they actually give birth. And some mothers switch to family-friendly jobs with less hours or more flexibility in anticipation of becoming parents before they actually become parents. So ensuring that couples are present at least 2 years pre-parenthood prevents my estimation of the motherhood penalty being underbiased. Next, I have an indicator variable for if the female partner changes partner. Then I have age and year fixed effects of both partners to counter for life cycle trends. Then I have a time trend and year fixed effects to counter for business cycle trends. So second, we have the key estimating equation for the sample age 20 to 60. The key variable is the indicator variable for being parents, which takes the value of 1 if both partners in the couple are parents, and 0 if both partners in the couple are childless. I then have a quadratic in age for both partners, or quadratic of experience for both partners, years of education of both partners, an indicator variable for being an immigrant that speaks English, an immigrant that does not speak English, which is compared to being Australian born, and continuous measure of number of children for both partners. I also include a time trend and year fixed effects. So Callaway and Lee, in a quantitative economics article of 2019, put forward assumptions for estimating a difference in differences model using quantile regression. And they claimed that to identify a quantile treatment effect of the treated, there had to be parallel trends across the distribution. So what this means is that in the absence of treatment or parenthood, a couple have to be presumed to have maintained their position in the couple's hours gap distribution if parenthood did not occur. So I test this assumption on the left of actual hours and on the right of desired hours. So what I do is I compute Kendall's tau for copulars of consecutive years pre-parenthood, -5, -4, -4, -3, -3, -2, -2, -1. And I look at these correlations bootstrapped across these copulars of years. And what I find is that the estimates are not statistically different for the 5 years pre-parenthood. So couples are not changing their position in the couple's hours gap distribution in the years pre-parenthood. So therefore, it's reasonable to assume that in the absence of parenthood, they will continue to maintain their position in the couple hours gap. Next, I have a different estimation strategy to test the parallel trends assumption across the distribution. So what I've done, is turn my DID model into an event study, and I compare the omitted coefficient -1, so 1 year pre-birth, with the coefficient -2 or 2 years pre-birth. And what you can see is that there's slight pre-trends in actual hours around the 7th and 8th decile of the couple's actual hours gap distribution and the 7th decile of the desired hours gap distribution. So I iterate this event study over 99 percentiles. But as I said previously, other researchers have found slight pre-trends the year directly preceding birth with event studies of motherhood. So here I compare the omitted coefficient 2 years pre-birth with the year 3 years pre-birth, and I find there's no statistical difference in these coefficients comparison. So this gives weight to my estimation strategy that it's sufficient to just require couples to be present in the sample at least 2 years pre-parenthood. So here are the results for the difference in differences model for couples' actual hours gap. So the first 3 columns are OLS regression. The second 3 columns are OLS regression with fixed effects. And the third 3 columns are random effects regression. A Horseman test reveals that the random effects regression is more efficient than the fixed effects regression. But what's quite striking is that for the post-baby indicator variable, across the 9 specifications, all estimates are relatively similar. And in columns 2, 5, and 8, I interact this post-baby indicator variable with the number of children alive. And what you can see is that the motherhood penalty is only slightly exacerbated by the number of children a person has. So roughly speaking, couples' actual hours gap increased about 17 hours upon the birth of a first child in the first 11 years of parenthood. Here are couples' desired hours gaps. So I estimate the same covariates as on the previous page. The first 3 columns are OLS regression, the next 3 columns OLS regression with fixed effects, and the third 3 columns OLS regression with random effects. And what you can see, once again, estimates are quite similar across the 9 specifications, and couples roughly desire for the hours to decrease according to parenthood, 14 to 15 hours. So according to estimates at the mean, couples' actual hours gap increased about 17 hours, and couples' desired hours gaps increase about 14 to 15 hours. So couples would like the hours gaps to be 2 to 3 hours less than what they actually are at the mean. But quantile regression tells an incredibly different story. So the black line here is the DID model estimated at quantiles. So what we can see is that OLS regression at the mean said that couples' hours gaps according to parenthood increased 17 hours. But what quantile regression says is that the first and second decile, and 8th and 9th decile, they actually only increase about 10 hours. Whereas at the 4th decile, it increases 30 hours, at the 5th decile, over 25 hours, and at the 6th decile, close to 25 hours. So there's great heterogeneity compared to the mean estimate of 17 hours. And the green line here are how couples would desire for their hours gap to change. And what you can see is there's relative homogeneity across the distribution of how couples would desire their hours gap to change post-parenthood. For couples at the 9th and 10th decile, that's reflective of there being overemployment. Couples would like their hours gaps to increase more than what they actually do, or for the male partner to work more than what he does relative to the female partner post-parenthood. So some females in the first 11 years of parenthood report being overemployed. In the middle of the distribution, there's a gap of 10 to 15 hours between couples' actual and desired hours, which is very different to the 2 to 3 hours estimated by models at the mean. And at the first and second decile and third decile, there's no statistical difference between couples' desired hours gap and couples' actual hours gap. So quantile regression tells a very different story to OLS regression. Here we have predicted values from the graph on the previous page. So on the left, we have couples' actual hours gaps, and on the right, we have couples' desired hours gaps. So couples' actual hours gap, what you can see is that pre-baby, they range from -40 to +10, and post-baby, they range from -50 to about 2. However, couples' desired hours gap range from about -20 to 2 pre-baby and -30 to -10 post-baby. So there's much more homogeneity in couples' desired hours gap than couples' actual hours gap across the distribution. Couples' desired hours gap distribution is much more contracted than couples' actual hours gap distribution. Now I turn to the sample age 22 to 60, where couples where both partners are parents are compared to couples where both partners are childless. My preferred specification is column 5, which is saturated with all control variables. Where I included experience as a quadratic, the AIC criterion indicated that age should be included as a linear term. So what this regression table says is that, roughly speaking, being a parent rather than being childless, couples would actual hours gaps of 14 hours greater. Then I look at couples' desired hours gap at the mean, and being parents rather than childhood in a preferred specification of column 5 is couples' desired hours gaps of roughly 11 hours. So like for the first birth sample, couples would desire for their hours gap to be 2 to 3 hours smaller than what it actually is at the mean. But once again, quantile regression tells a very different story. And the black line here is couples' actual hours gap, and the green lines are couples' desired hours gap. So while we had 15 hours at the mean for couples' actual hours gap, at the first and second, 7th, 8th, and 9th decile, there's actually only a 10 hours gap, whereas at the third decile, there's a 25 hours gap, at the 4th and 5th decile, a 20 hours gap, and at the 6th decile, a 16 hours gap. So quantile regression reveals much greater heterogeneity compared to OLS regression that is masking this heterogeneity. And couples' desired hours gap is what's really striking. In the middle of the distribution, there's 15 to 20 hours gap between couples' actual and desired hours, which is much different to the 2 to 3 hours from models estimated at the mean. And in the first and second decile, there's actually no difference between couples' actual and desired hours gaps. Here are the predicted values from the previous slide, and we see the same trends as for the first birth sample. There's great heterogeneity in couples' actual hours gap, but the desired hours gap distribution is much more contracted and homogeneous across the population. And actually, for the 10th decile, there's no statistical difference between parents and childless couples' desired hours gaps. And the 8th and 9th decile, the difference between parents and childless couples' desired hours gaps are very, very small. So in terms of inequality indices, I utilized two, the squared coefficient of variation and the Gini coefficient. So Cal identified the four most desirable properties of inequality indices: anonymity, population invariance, scale invariance, and the Pigot-Dalton transfer principle. So the Gini coefficient and the squared coefficient of variation both have all four of these properties, as well as being robust to the inclusion of zero values, which is important considering some people have 0 actual hours, 0 desired hours, and 0 earnings. The squared coefficient of variation, crucially, has the property of additive decomposability. This means that the squared coefficient of variation can be decomposed by population subgroups, in my case, mothers and fathers, and expressed as a within group and between group component. One of the key variables I apply inequality indices to is desired weekly earnings that I feel I have to define. So desired weekly earnings is a person's actual hourly wage multiplied by their desired weekly hours. I utilize the longitudinal nature of Hilda and impute an individual's hourly wage with the most recent wage recorded if they were not working the week of the interview. This derived hourly wage variable is a good indicator of the value of a person's work in the labour market, whether they were working the week of the interview or not. So here we have two strikingly different graphs. On the left, I have the hourly wage with inequality indices, and on the right, I have yearly earnings with inequality indices. So for the hourly wage, what we can see is that inequality indices don't change according to parenthood. There is more within inequality than between inequality, but the Gini coefficient indicates that both males and females are roughly relatively unequal. On the right side, we have yearly earnings, and here we can see within inequality, the black bold line is much greater than between inequality, the dotted line. We can see that with the father's Gini, the blue line, hardly changes due to parenthood, but the mother's Gini increases at the time of first birth. So there's more within inequality than between inequality. This within inequality in yearly earnings is exacerbated at the time of first birth and is due to inequality within the group of mothers rather than within the group of fathers. And what we can see is that there's the quantity of labour rather than the price of labour, which is the key to understanding inequality in the Australian labour market. On the left here, I have actual hours and inequality indices, and on the right, I had desired hours and inequality indices. Once again, within inequality peaks around the time of first births, but the father's Gini is not perturbed by becoming a parent. It's the mother's Gini that spikes at the time of first birth. So this within inequality is being driven by inequality within the group of mothers rather than within the group of fathers. But what we can see, comparing the graph on the right with the graph on the left, is that if mothers were able to work their desired hours, the within inequality within mothers due to hours would decline, and also the overall Gini of mothers would decline if they were able to work their desired hours rather than actual hours. This is because some mothers are overemployed and some other mothers are underemployed. So finally, I compare actual weekly earnings with my key variable, desired weekly earnings. Actual weekly earnings are on the left, desired weekly earnings on the right. So actual weekly earnings, again, the within inequality is greater than the between inequality, and it spikes around the time of first births. And the Gini coefficients reveal this within inequality is being driven by inequality within the group of mothers rather than inequality within the group of fathers. Fathers' inequality does not change due to parenthood. And on the right, we see desired weekly earnings, that if couples were able to, if parents, mothers and fathers were able to work their desired weekly earnings, within inequality would be much less than the actual weekly earnings within inequality that we observe. And mothers' Gini would be much less in magnitude for desired earnings than what we observe with actual earnings. But as I alluded to in the introduction, overemployment and underemployment have opposing effects on the hourly wage. So these inequality earnings for desired weekly earnings, these inequality indices for desired weekly earnings would actually be even less if couples did not experience overemployment and underemployment. So in conclusion, there are three main findings in this article. First, econometric models estimated at the mean can be very misleading. Second, isolated desired hours relative to individuals' position in actual hours distribution. This reveals underemployment and overemployment to be more pervasive than previous research. Third, inequality measures calculated around the time of first births reveal the importance of the quantity of labour rather than the price in creating inequality. There is greater earnings inequality within the group of mothers than between mothers and fathers, and this within inequality is exacerbated at the time of first births. Earnings inequality would demonstrably decline if mothers could work their desired hours. The primary economic policy considerations stemming from this article is perhaps policymakers should focus more on reducing inequality between females or within females rather than reducing inequality between females and males. Perhaps policymakers should look at how gender intersects with other aspects of a person's identity, such as their ethnicity, their socioeconomic status, their education level, their religion, their disability, their sexuality, or their location, to help design policies that alleviate the lifelong reduction in earnings of some mothers. Conceivably, it is not gender that is the driving explanation of the motherhood penalty. It is how gender intersects with other aspects of advantage and disadvantage that create the heterogeneity that I documented in this article. Researchers should attempt to understand why there is such significant mismatch between mothers' actual and desired labour supply, and policymakers create interventions that help alleviate this mismatch. Underemployment and overemployment have been linked to unhappiness, anxiety, and depression. If underemployment and overemployment did not exist, this would directly improve mothers' personal well-being. Furthermore, reducing underemployment and overemployment would also cause earnings inequality within society to decline, which would have a positive externality on both females and males' well-being. Although beyond the scope of my article, which was merely the first step in documenting the disutility that exists, the mismatch between desired and actual hours due to parenthood, my findings suggest that policy interventions are needed to alleviate this mismatch. This could include increasing paid parental leave for fathers, which would presumably decrease the amount of time some mothers leave the workforce when their children are young, increasing the availability and affordability of childcare, or offering subsidised retraining programs to females to leave the labour market for an extended period. Businesses could also put in place policies that enable workers to be closer substitutes. I hope you've enjoyed listening to my presentation. If you have any comments, please email me at jane.wakeford@anu.edu.au.